how can we use this equipment to measure the specific heat capacity of this metal? Pause the video now and discuss this question. So we obviously need to know what the specific heat capacity means. So specific heat capacity is the energy needed to raise the temperature of 1 kilogram of something by 1 degree Celsius. We can also express that as an equation. So here it is. Specific heat capacity is the energy needed to raise the mass, 1 kilogram of something, by a temperature of 1 degree Celsius. Sometimes you will see these symbols, energy and change in temperature. The triangle means change in, and one of these two symbols means temperature. So what measurements do we need to take? Well, we need to know what electrical energy is equal to. It's equal to current times potential difference times time. And we obviously therefore need to write these down, as well as the mass and the change in temperature. The change in temperature is really easy. You measure the temperature at the start and you measure the temperature at the end, and you subtract the start from the end temperature. So these are the 6 things we need to write down. What circuit do we need to build? We need to build this circuit. It looks complicated, but it's really straightforward. Power supply connected in series with an electric heater and an ammeter and a voltmeter that measures the potential difference connected in parallel across the heater. So let's show you how to build that circuit. So I'm going to make some space. I'm going to get a heat-proof mat so I keep the table safe and not burnt. I'm going to get my metal block and I'm going to put my electric heater in it. I'm going to take a single wire and connect the power supply to the electric heater, and then I'm going to take a wire from the other side and I'm going to put it in one side of the ammeter, and I'm going to take my final red wire and put it in the other side of the ammeter. So if I was to spread this out, I would have one loop with this in first and then this in second. I'm then going to get my voltmeter and I'm going to connect that in parallel across the thing that I'm trying to measure, so across the heater. So I get one wire and connect it in one side, and I get my second wire and I connect it in the other side. I'm then going to take one of those wires and put it on the left side of the heater and the other wire on the right side of the heater. It's really important you do this stage second. So now I'm almost ready to go. I'm going to put my thermometer in, and I'm just going to take this out before I start my experiment to do a quick test. So let's turn this on and see if it works. If it doesn't work, you might have done something as silly as not turn on the plug. So there we go, I've turned on the plug and it's working. Now if you do not get a reading on these, I suggest you do a couple of things. One, you check that this is on DC for direct current and not AC. It won't work unless it's on DC. And check that the safety fuse is pushed in. Sometimes this pops out. If it still doesn't work, check that you've got a really good connection here, so push it right in. And if it still doesn't work, one at a time, take out the wires, swap them for a different wire, and check that all of the connections are really good. Sometimes these can be a bit loose. The final thing I need to check is that both of these numbers are positive. This one is positive, this one isn't. So what this means is the negative is connected to the positive and it should be connected to negative. So it's really easy to fix. I just take out the wires from either side and I switch the sides in. So now the positive is connected to the positive and the negative is connected to the negative. So now I'm ready to go. I turn this off. I will obviously make sure it's as neat as possible. This is a bit of a mess, but I'm just going to get it on the screen. I put the heater back in and now I'm ready to go. So I get my stop clock ready. I would turn this probably to 6 or 9 volts to make it go a bit faster, but this is just an example. I'm just going to leave it on 2. And on the count of 3, I turn on the power supply and the heat and the stopwatch. What I can do while I'm waiting is I can write down what my current is. I can write down what my potential difference is, the starting temperature I can write down, and the mass of this, which is found from a mass balance, I can write down. I wait about 5 minutes and then I stop the stopwatch. I then am going to wait another minute or 2 and I'm going to write down the maximum temperature that I get to, because sometimes the heat from the heater takes a little bit of time to get to the thermometer. So I'm going to write down the maximum temperature here and then I've got everything I need. The change in temperature is the final temperature minus the starting temperature, and then every other number I've written down, so I can put these in this equation and work out my value of heat capacity. Easy. If I have time, I will change the metal, and if I don't, then that is the practical done. Now, there is one other way you might want to do this. It's a little bit more complicated, but it does have some advantages. What I can do is I can plot a graph of temperature against energy supplied. And if you do that, as we supply energy, it takes a little bit of time, and then the metal starts to heat up in a linear fashion. So this will be a straight line. And what I can do is I can work out the gradient of this line. So the change in temperature over the change in energy gives me the gradient, and I can use that to work out a value for my heat capacity. So I'll just very quickly show you how to do it. This is the equation for heat capacity. Energy is mass times heat capacity times temperature change. I can rearrange this to get it into a straight line equation. Y equals mx. So this is y, this is x, and this is the gradient. And then I can rearrange this equation to get heat capacity equals 1 over the gradient, and that's the gradient, that's 1 divided by the gradient, multiplied by mass. So this is another way I can get heat capacity, but from a graph.